All right, we are about to begin Chapter 2, Electricity. We are now on Section 3, all about batteries. Be sure to have your notes ready to fill in the blanks. All right, the first battery. Before we start talking about batteries, just a few things I want to lay the groundwork for. Energy. Energy, as we've learned before, can be transformed from one form to another. In the case of batteries, batteries transform chemical energy into electrical energy. Now, remember, chemical energy is stored in the bonds of atoms. So remember what chemical energy is. So more about the first battery. Luigi Galvani was studying the anatomy, or also known as the body, of a frog. He has a brass hook holding the leg of the frog in place. As he touched one end of the hook to an iron railing, you can see here the iron railing, one end of the hook to an iron railing, he noticed that the frog's leg twitched. He said. He hypothesized that there was some animal electricity existing only in living tissue. So that was his hypothesis, remember, his educated guess. He was later proved incorrect, but it did get people thinking, or scientists thinking, about what was going on. Why did he note it? Why was there some sort of twitching in the frog's legs when those metals touched? Alright, so Alessandro Volta developed a different hypothesis to explain Galvani's findings. He said the effect that Galvani observed was a chemical reaction. A chemical reaction is a process in which substances change into new substances with different properties. Volta said that a chemical reaction occurred when the two metals, the brass and the iron, came together and mixed with the salty fluids of the frog. To confirm what he hypothesized, he placed a piece of paper that had been soaked in salt water in between two pieces of metal. He used zinc and silver. You can see in the diagram here to the right, you've got zinc, you've got paper soaked in salt water, and then you have silver. He found that if he connected a wire to the metals, that a current was produced. The more layers of salty paper, zinc, and iron that he laid down, the greater current that was produced. Volta built the first electrical battery by layering zinc, salty paper, and silver. Volta's battery is the basis of modern batteries being made today. Alright, electrochemical cells. An electrochemical cell is a device that transforms chemical energy into electrical energy. In Volta's experiment, each pair of zinc, silver, and salty paper was one electrochemical cell. Each electrochemical cell consists of two metals called electrodes. Get to know that term. So you've got two metals called electrodes, which are immersed in a substance called an electrolyte. An electrolyte is a substance that conducts electric current. Volta used silver and zinc as his electrodes and salt water as his electrolyte. In the figure to the left, the electrolytes are copper sulfate and zinc sulfate separated by a barrier and mixed with water. So the electrolytes, remember, it conducts electric current and it is the solution. So this you have on this side zinc sulfate, and over here you have copper sulfate separated by a barrier. So the liquids aren't mixing, but in essence, charges can flow through it. The electrodes are made of copper and zinc. So again, you've got this is your electrode made of zinc, and this is your electrode made of copper. The part of the electrode above the electrolyte solution is called a terminal. So here you've got one terminal, just the part that goes above the electrolyte solution, so the zinc terminal, and over here you've got the copper terminal. So each of these that are above the electrolyte solution are called terminals. They are used to connect the cell to a circuit. So you can see how there's a circuit connecting it, and that is where a current can flow. Alright, chemical reactions occur between the electrolyte and the electrodes in an electrochemical cell. These reactions cause one electrode to become negatively charged and the other to become positively charged. Because of their opposite charges, there is voltage between them. Remember, voltage causes charges to flow. The voltage is the difference between the charges. So because there's two different charges and there's a difference there, voltage can flow. If the terminals are connected to a wire, charge will flow from one terminal to the other. Electrochemical cells cause charges in an electric current in a wire. The barrier, remember that barrier we saw, allows charges to flow through through the electrolytes to make a complete circuit, but prevents the copper and zinc from mixing. So, and you can see here in this diagram, you've got a positive terminal and a negative terminal, which creates a potential difference, and the difference is what causes voltage to be able to flow. A battery is actually the term for a combination of two or more electrochemical cells in a series. You can see batteries that we use in a flashlight could be called electrochemical cells. The positive terminal of one cell is connected to the negative terminal of the next. So you can see here you have a positive end to the battery. Over here is your negative end. You connect them up, and there's a potential difference. You can connect two cells or batteries in the same way. The total voltage of a battery is found by adding the voltages of each individual cell. So you would add the two voltages of these together. Alright, wet cells and dry cells. There are two types of electrochemical cells, wet cells and dry cells. An electrochemical cell, or aka a battery, in which electrolyte is an actual liquid, is called a wet cell. Volta's battery from the experiment we talked about previously was a wet cell because the electrolyte fluid was salt water. Now, automobile batteries are wet cells because they have electrolyte fluid, but it's not water or salt water, it's sulfuric acid. So those are considered a wet cell. A dry cell is an electrochemical cell in which the electrolyte is a paste. Flashlights and many other devices use dry cells, so that's probably what you're most familiar with. Okay, answer the following questions on a separate sheet of paper, or you can write it in the space provided on the back of your notes paper. I left some room for you to answer these questions. So question 1. Describe the parts of Volta's battery and how they were arranged. Question 2. What happened when Volta connected the parts of his cell to a circuit? Question 3. What caused the process in question 2 to happen? Question 4. What are the parts of an electrochemical cell? And question 5. Would a terminal work if both terminals were the same charge? Why or why not? Alright, be sure your notes page is filled out, these 5 questions answered, and vocabulary is finished for this section, and you can take the test on QuizStar. Good luck!